let's talk about embeddings. Embeddings are a way to represent complex or high-dimensional data like words and images as vectors of numbers. For the purpose of this exercise, let's just think of them as a list of numbers. So you can take a sentence and represent that as a list of numbers. And we can go as simple as that and get some level of understanding of what it means. So converting a sentence into a list of numbers. Now, why is that important? Why is that good? Because we can compare numbers a lot easier than words. There are mathematical formulas to do so. So let's say you have a bunch of documents, basically a whole mess of information, and you have a query. Now, query just means you're asking something about your body of documentation. For example, if your documents is a list of sports data, you would say your ask would be who won the last NBA final. So that's an ask. So where does embeddings come to play? We take these documentation, this information, and we convert them into embeddings, which are vectors of numbers. So we have numbers here, and then we're going to take the query and convert that into an embedding. Again, a series of numbers. So we have numbers here. So we take the number which represents the query and the numbers which represents the documents, and we do a similarity computation, meaning given my query now converted into a vector, find me the closest list of vectors from the documents list. So you're basically doing a comparison. Right? So what they call it the semantic similarity. What that means is get the meaning of my query and find information in my list of documents that has very similar meaning. The output of that comparison is a list of embeddings. So you take the embedding of the query, and the output would be, let's say, 3 or 5 embeddings that are very similar to what the query means. Okay, so let's look at some code. Line number 2, we import a library which would transform our sentences, our documents into embeddings. So number 4 right there, that's the model that we use for conversion. And then line number 6, that's our list of documents, which we will turn. So let's look at the diagram again. So step 1, we take our documents, convert them into embeddings, and that's what we're going to try to do now. So back to our code, that's our list of documents. We call encode in order to turn those documents into embeddings, and we have a way of displaying that nicely. So we can see that this first sentence produces this vector right here. Second sentence, cats are independent animals, produce this vector, and third sentence produce this vector. So let's go to our second script. And the second script, what it does is it takes the sentences from the documents and does a similarity comparison with each other. So sentence 1 compared to sentence 2 compared to sentence 3. So we take our documents, we embed them, and here's the new part. We take a cosine similarity function, so we pass that our embeddings, and we get similarity scores. So line 25 gets the similarities. All right, so the top part, that was outputted from the first script. And here you see sentence 1 compared to sentence 2 got a score of 0.144. And the higher the number, the more similar they are. And 1.0 being identical, the lower the number, obviously, the less similar they are. So sentence number 1 and sentence number 3 got a slightly lower score. So Python is a programming language, and dogs are loyal plus. I mean, these are all very low scores. But when we get to sentence 2 and 3, we get a much higher score just because cats are independent animals and dogs are loyal pets. are similar in meaning. So definitely more relevant, and the scores there are higher. And going back to our diagram, so step one was taking our documents and converting them into embeddings. So that's done there. We even did a comparison between each sentence in the document. Next step would be taking a query and converting that into an embedding. And moving on to our third script, what we have here is a list of documents. So it's a lot more now, and we take these documents and we embed them as usual. And now we have our queries. What is machine learning? Tell me about programming languages, informations about animals. So these are queries that we will turn into embeddings, and those embeddings then gets compared with the documents. Going back to our terminal, let's run script number 3. And again, this is what's doing the similarity comparison between queries and documents. All right. What we have here is the result of the first query. What is machine learning? And it tries to find the most relevant sentences in the document. So number one, machine learning uses algorithms, so very relevant. You see that it's a pretty high score of 0.75. And then number two, AI, deep learning, slightly less relevant. And then number three, Python is popular for data science, even less relevant. As you can see, the lower the number, the less relevant. The higher the number, the more relevant. Query number 2, tell me about programming languages. As you can see, what it pulled up is about the Python programming language. Python is for data science, so it's 0.68, 0.675, so it's a good score. Less relevant would be Python is for data science, and then even less relevant is Java. No surprises here. Moving on to our third query. Now the sentences about pets and dogs and cats are appearing just because the query talks about animals, and these are those sentences which receive the higher similarity scores. Let's go ahead and review our diagram. So we completed number 1, number 2, where we take a query, embed, and also step number 3, we compare the embeddings and we produce a list, which we just saw here. So that's the completion of the entire flow. Please like and subscribe. All the code I used is available in the GitHub repository, linked in the description below.